Albert Einstein was right when he predicted that we would never be able to see the edge of the universe. The James Webb Space Telescope, JWST, has now observed a void in the extremely early universe that could confirm this prediction. But what are we really seeing here? Is it really a void? And could it be the beginning of the universe? Scientists may have discovered a shocking fact. A strange void at the beginning of time may now confirm a remarkable prediction by Albert Einstein. Imagine how 100 years ago scientists slowly began to look beyond the edges of the Milky Way. What they saw astonished them. At first, it was just hazy nebulae, but then it became clear that these nebulae were other galaxies. First, the Small and Large Magellanic Clouds became visible, then the Andromeda Galaxy, and finally the shock. Scientists realized how many more galaxies there were. Based on these findings, ideas such as the evolution of galaxies and the infinity of the universe were born. Then Edwin Hubble observed that distant galaxies were moving away from us, and the idea of expansion was born. Shortly afterward, the Belgian Georges Lemaitre came up with the Big Bang theory. This all took place slightly after the time when Albert Einstein presented his theories of relativity. Many of the researchers' theoretical predictions, which had been made in the 1910s and 20s, had been shown to be accurate with the aid of these new discoveries. However, Einstein was unsure throughout his life whether the universe truly had a beginning and an end. Although he fundamentally supported the Big Bang theory, Einstein was always focused on another interesting question. Even if the universe did have a beginning and an end, he was certain that we might never be capable of seeing this beginning or end, regardless of how good our telescopes became. How did Einstein come up with this seemingly crazy idea? And what does it have to do with the void found by the James Webb Space Telescope? Einstein was truly one of the most important physicists of the 20th century, and he made many predictions that are still cornerstones of cutting-edge technology today. One profound realization was the aforementioned prediction that we could never directly observe the absolute beginning of the universe. Einstein gave two exciting reasons for this. Firstly, the concept of the Big Bang and related theories postulated that there was no light for hundreds of thousands of years immediately after the Big Bang. Today, scientists call this epoch the Dark Age. So how could we observe a point in time or an event with telescopes if there was no light? There are even some fascinating answers to this question today, such as radio telescope. These don't see but rather hear. However, researchers are quite certain that the Big Bang was not a loud explosion but occurred in total silence. Basically, the space in which an audible explosion could have taken place didn't even exist at the time of the Big Bang. Space itself only came into being with the Big Bang and was shaped as a result of this event. Radio telescopes detect waves, typically in the audible sound spectrum. Space hardly conducts any sound, and only some types of waves penetrate the interstellar medium. These can be made audible using modern technology. We would therefore not really be capable of hearing the presumably silent beginning of the universe. We discovered the cosmic background radiation back in the 1960s and have since mapped it in great detail. This radiation is considered an after-effect of the Big Bang, and much of the evidence for the Big Bang has been derived from it. However, the microwave background has never led us directly to the Big Bang. So here, too, we seemingly have no way of detecting or proving the absolute beginning of the universe. But Einstein also had another reason to believe that we can never see all the way to the beginning or edge of the universe. He believed that the beginning would move farther and farther away from us due to the expansion of the universe and would, therefore, be out of our range of vision, so to speak. Albert Einstein also believed at times in the curvature of all space. This means that the starting point could also be behind a sort of horizon that would forever obscure our view. Now imagine again that this was at a time when the best telescopes were only capable of blurring neighboring galaxies. Today, we know of the existence of hundreds of billions of galaxies in a universe teeming with them, expanding so much and growing bigger and bigger. It may seem really difficult to peer very far at all, but that's not true. Although our cosmos is so rich, the areas between galaxies and galaxy clusters are so vast that we can now see 13.6 billion years away with our telescope. That's incredibly close to the Big Bang. And with the James Webb Space Telescope, we're already very close indeed. I'm sure you've heard that the JWST has discovered an exceptionally large number of very, very old galaxies, some that even call the Big Bang into question. But did you also know that the JWST has detected an odd void that could confirm Albert Einstein's prediction about the non-observability of the absolute beginning? Absolute voids are mysterious regions in the universe that are so empty they virtually contradict the principle of relativity. But how can it be that they confirm Einstein's idea about the invisibility of the beginning? This is initially explained by the fact that the vacancy was thought to be a representation of the Dark Ages, where there wasn't much, at least not stars and galaxies. Some researchers believed the discovery had at least confirmed the existence of this epoch. But then came the shock. The darkness turned out to be an exceedingly distant void. We also know of closer and more recent void. These voids already pose puzzles. But in the extremely early universe, voids are once again scientific impossibilities. They do not fit into the theory of the homogeneity of the universe, which is directly tied to the concept of the Big Bang and expansion. Voids are too large and too unusual. They have an inhomogeneous nature and contradict some of the core principles of our cosmology. A void does not truly confirm Einstein's prediction, but the Webb telescope seems to support the great scientist's views in another way. It has, so far, detected no trace of a beginning or an early phase of the universe. The images of the allegedly extremely early universe only show structures and galaxies that do not appear very different from those we know from the observable universe. The question now arises: could a mysterious void have been the beginning of the universe? We cannot completely rule this out because ultimately we never truly know what voids are. Today we also have to admit that we do not understand how the universe actually began. Voids are probably empty, but we don't know that for certain either. It's possible that they contain some kind of matter we don't yet understand. Imagine dark galaxies. Voids are sometimes interpreted as some kind of parallel worlds. Some scientists see them as scar tissue from the collision of universes in the multiverse. Other wild theories claim that aliens darken the galaxies in a void to harvest energy. So you can already see that these mysterious voids challenge our scientists and give rise to the craziest theories. Of course, it could be that our universe was created in a massive void. The mere fact that we cannot prove the opposite reinforces such an idea. That leaves the question of how our universe was created. We've already mentioned the nothingness from which the universe is said to have emerged. If that was truly the starting point, how could we observe it? After all, it was nothing, and therefore not detectable by us. A singularity is a point at which all forces are so condensed that our dimensions of value and size fail, or everything that exists is concentrated into this one point. This point consisted of a fluctuation of possibilities that existed in a state of perfect equilibrium. A previously unknown event is said to have disturbed this standstill at one moment, and creation began from this tiny point. Everything that we know and can see today came into being from this process. This means, no less, that the information for you and me, all life on Earth, every megastar, and every exoplanet was contained in this tiny dot of nothing. The question of how an infinitesimally small dot of nothing could contain everything is one of the great mysteries of science, and it is currently unclear whether we will ever be able to solve this puzzle. We find these mysterious singularities in another place in the universe, specifically at the centers of black holes. These, in turn, are found at the core of nearly every known galaxy. Black holes are what remain when stars of a certain size explode. At least, that is what scientists suspect. No one has ever been to the center of a black hole, and as we've discussed, we hardly have any way of seeing the absolute starting point of the universe, if it existed at all. Everything is based on calculations that made sense, until the James Webb Space Telescope discovered something different from what our theories predicted. The Webb telescope shows that the universe may be much older than we assumed, or that its nature is quite different from what all our calculations expected. Black holes, too, remain one of the great mysteries.